was able to get off the plane, start up my phone, get access to my email, download all the reports that I wanted to check from this morning, make a few calls. In general, plenty of bandwidth, plenty of availability of connectivity to the internet, easy to make calls. Okay, so that's the story today. Let's fast forward a couple of days to when 180,000 people descend on the city. And what's going to happen? All right, there's going to be a huge demand on our data centers, trying to service all the data that everybody's going to be pulling down. It's going to strain the network. We'll all be waiting for downloads. We're going to be dropping calls because of all the folks competing for network bandwidth. It's a pretty miserable experience. So this is what we have to solve in order to make the cloud a pleasant experience for everybody. Otherwise, it won't fulfill its promise of putting that data everywhere that we need it. So I'm going to go through a few things. First, I'll start with what we mean by data ubiquity. So it's a bit of an SAT word there for you. But we're talking about putting data in your hands anywhere, anytime, on any device, whatever form factor that you're using. We're really trying to make a great experience of that. Okay, there's several challenges that we'll go over in a lot of different places in the infrastructure of the cloud. And the good news is for everybody in the storage industry, the storage plays a big role in solving these challenges, both HDDs and flash storage. So I'm going to go through this. I'll start with SanDisk's view of the cloud from what we say is the first node to the last node. The first node being our data centers, our server farms, where all this data is served up for our applications, transmitted over data networks to our client devices. And the client devices, we're talking about cell phones, tablets, clamshells, PCs. So along all the different parts of this, there are challenges that have to be overcome to make the cloud work the way that we all envision it. So we'll talk about the first node, the server farms and the data centers. Power consumption is one of the biggest challenges for all these. Back in September of last year, New York Times published an article on a Fishkill data center for Google that was consuming 260 megawatts. So that's equivalent or more than the energy consumed by Salt Lake City. So it's a huge amount of power that these data centers are sucking up. Those data centers also have a huge amount of space. So the real estate that they take up and all the equipment that's going into them will pose a huge cost of doing these data center build-outs. So those two challenges amount to huge cost problems. The power consumption actually turns out to be even a higher cost than the build-out itself. To make it work the way it's supposed to, we have to address a lot of performance challenges, and we'll go through how the storage architecture is helping that. And then, of course, we want our data to be stored reliably in that cloud. So, how has this been approached in the past? Disk drives have been, of course, the standard storage medium of choice for these data centers. In order to address the performance issues that the disk drives have, we've gone to faster spindle speeds, going to 10K, 15K drives. We've done a lot of tricks trying to overcome seek latencies using short stroke, low capacity, small form factor HDDs, taking a lot of these HDDs and putting them in parallel, striking the data across them, trying to get our megabytes per second up. What that's done is present a huge challenge, again, for space and power to actually keep up with the demand. So a lot of hybrid configurations have been all the rage for the past couple of years and are really coming into fruition now. We're able to see storage tiering where the hot data is served up from SSDs, from these very high-performance dual-ported SAS drives, being placed in conjunction with the colder data that's being stored on the hard disks behind. And because we've offloaded the performance bottleneck from the rotating storage, we can actually use larger hard disks. Of course, everybody, when they talk about hard disks or solid-state drives, always talk about the 100x cost difference between a hard disk and a rotating storage. The net result of this, because we are looking at a system implementation, is actually the net result is lower cost for the guys doing the build-out. So to go through how this works out in an example, I'll take some data from the TPC website. So this is a website where a lot of the system builders post their bragging rights. These are like their Formula One track titles. So the metric of interest is the cost per transaction per minute. So there was one posting in 2008, HP in one of their server racks was able to serve up $1.10 per terabyte per minute. They 2 years later posted a new one showing 0.65 cents per terabyte per minute. The difference between these two is one is using a rotating array, one is using a hybrid array. This is actually the difference between these two is that we were able to increase capacity by almost 3/4, serve 2/3 more users with that same rack. The performance of the rack went up by 60%. That is then showing the advantages of using tier storage. Actually, our power went down. The power went down almost 80%. The footprint went down 77%. So it went from 3 full-size racks to a half rack. And overall, the system cost was 5% lower. So this is just one example of where tiered storage is helping to overcome some of the challenges of these server farm build-outs. So this is on the storage side. Also going to show, step a little bit further into the future and show another interesting application of technology where power and footprint are the main focus. So I'm showing here a comparison of server racks between your standard Intel-based server racks and one that's being architected by Calxeda, which is a company that has a very unique using quad ARM cores as the servers here, coupled with not rotating media, but actually mSATA, very small SSDs. So taking that 6 racks and shrinking them down to 1 rack, to able not only to keep the same amount of computing power, but actually increase it, going from 240 servers up to 720 servers. That additional server bandwidth is accompanied by a huge reduction in the power consumption, going from 55 kilowatts down to 4.4 kilowatts. So we end up with 92% less energy, 83% less space consumed, 40% lower cost. All right, so you can see that a lot of people are working both on the data side and on the server side to address some of these challenges. Okay, so a lot of people working on the first node. Now, that thing in between our client devices, server farms, and the data centers is that data network. Now, obviously, storage can't be floating about helping on the transmission of our information, but actually storage can help us solve some of the problem in coverage area, in our available bandwidth, and address download speeds. So high quality mobile experience, HQME, is a consortium that's led by SanDisk and an infrastructure by which we look at the bandwidth of the network and we try and leverage the underutilized off-time bandwidth that and cache data and store that in local storage. So there's basically 3 elements to this. So starting with the device itself. If we cache data intelligently, we're able then to control when that data is pulled over that network. Now, if we put a good heuristic on our device, we can find that actually most of us are pretty predictable in our data consumption. Either for myself, pulling down email at certain times, pulling down regular reports that I get from Asia overnight or from Europe. All this information is stuff that we do on a regular basis. It's not like we just think, oh, I want to check out a YouTube video. Also, our kids, for example, I just had the fortune to be in Hawaii for a vacation, and my daughter wanted to watch her PBS shows, right? She's watching the same shows every morning, or she's watching the next episode, all very predictable consumption of media. So putting these heuristics on the device, caching the information at times when the network is not super busy trying to serve up everybody's information is the way that we can help offload that data from peak power. Another interesting article from New York Times, actually just from 2 days ago, said that 50% of the world's bandwidth is being consumed by 1% of the network users. So we actually don't have to do too much to affect a few of these users and improve the information, get it off the network's peak hours. And we could have fundamental change in the network loading. So, and of course, using Wi-Fi when it's available for shifting load to other networks when possible. All right. So So that says that we need to have some storage in our client devices. Now let's go to those devices themselves. What we want is a mobile experience that we can get to that data whenever we want it on whatever we're using at the time. We want ultra mobility. We want longer battery life. We want those devices to come instant on. We don't want to wait for boot times. We want those applications to launch instantly. We want them to be ultra reliable. But we don't just want this in our phones and our tablets, which we come to use. A lot of us, for productivity reasons, need to have larger screens. We need to have keyboards. I'm not ready to give up the clamshell just yet, but I'd love to have that experience that I get when I'm using a tablet or when I'm using a cell phone. So this vision of how a clamshell device is a mobile device is something that has gotten a lot of notoriety. This is dubbed the year of the Ultrabook by Intel, and which is their initiative to address a lot of these issues in mobile computing. So I'm going to show you one example here, which is the Asus ZBook UX31. This is a very thin, sleek device, which is using SSDs to address some of these challenges. We're looking at very thin device, going from 3 to 9 millimeters on the chassis from front to back, 8-hour battery life, looking at 2-second boot from hibernating. So this, for all intents and purposes, is now becoming more like a mobile device and still giving us that productivity. Again, coming to rely on SSDs and what they enable from a form factor and a performance point of view. Of course, I'm talking about new initiatives here, but already all of us, all our cell phones and our tablets are running off of either ROD-N or eMMC today. So storage is in these devices, and in order to give those experiences and enable the stuff we've been talking about in terms of caching, storage will be there for the long run. So I believe that we have a bright future on the cloud, and I think it's time to look at some numbers to see what sort of future that might be. So the first number we're going to look at today is an IDC number. 2.7 zettabytes of information is going to be created and consumed in 2012. Now a zettabyte, 2.7, that's a huge number. It's very hard for you to get around, get your mind around that number. But to give you an analogy, that's 10 billion Milky Way galaxies worth of stars. So that's just to show you that the number's a lot harder to get your mind around than even that. So a lot of storage has to be built out to take care of this. And this doesn't, by the way, include the whole history of data that's been created to this point. Fast forward a couple of years to 2015, it's going to go to 8 zettabytes. So this is increasing at a fairly good clip, and we have to keep up with it. And of course, all this creates great opportunity in terms of the economies that are trying to keep up with the $60 billion being spent on cloud hardware, software, services, and build-out, going by 2020 to $5 trillion for all the communication networks and server farms, etc. 5 trillion. That's bigger than the 2010 top 5 economies in the United States: California, Texas, New York, Florida. So if we go down and to look at what this means for storage, and here I'm showing what's happening in the on the left side here on the storage side. Enterprise SSDs are growing at a phenomenal rate over the next 5 years. This is being predicted. So that goes along with what we all expect from the cloud, right? As more stuff goes to the cloud, they're going to put more in the SSDs. But it doesn't mean that now we don't have storage in the client devices. SSDs in the client are growing also at a very rapid rate. So it's obvious that storage has to be in both places to make this happen. And I'm being very focused on SSDs, but don't get me wrong, still people are built by lots of rotating media as well, both in the storage, both on the storage farms and in the data centers, as well as on the clients. So let's be honest, it's going to be a long time before the cloud is addressing all the markets around the world, and people do have to travel to these, and there's going to be need for certain markets to have a lot of that storage. SSDs are also being used in conjunction with that rotating media, both in hybrid and in side-by-side configurations, to start to try and get some of the experience that we were talking about in the mobile experience. Not quite getting there. A lot of growth in the client happening. So I'm going to conclude now just summarizing and saying, in order for the cloud to get the data everywhere, anytime, consume it the way we want, to give the great user experience, we have to address these three challenges, and we have to do it quickly because the market's growing at a rate that it really needs us to keep up. So I want to thank you very much for your attention today, and I hope that my predictions for a miserable data consumption experience over CS don't come true.